Hi everyone, and welcome to this Coindesk webinar sponsored by BTL. Today we're going to focus on private blockchains, their potential and their limitations, as well as on how those limitations can be overcome. Joining me today, we have a panel with deep expertise and interesting insight. I'll let them introduce themselves. We have Tom Thompson and Mark Barber from BTL, as well as Andreas Freitag from Accenture. Tom, let's start with you. Tell us a bit about yourself and BTL.
Thanks, Noel. So I started working at BTL trying to make resilient systems and reliable systems, particularly assembling them out of unreliable components. And to that end, we found that blockchain was the best way to achieve that. So we've been working on a blockchain that we built from scratch for the past 2 years, and we're about ready to release it at the end of this month. So that's me.
And this is the Enablement blockchain, is that correct?
That's correct, yeah.
And can you give us a very brief description of how this is different from, say, Hyperledger or Ethereum or some of the other ones that the audience might be more familiar with?
The biggest difference about this blockchain is that it uses multiple chains instead of one chain. So we found that very early on with our work with Visa that privacy was actually the main problem, privacy of actual data and privacy of metadata. So by making a system where each blockchain is a privacy realm, so to speak, and then allowing the chains to connect and communicate in a very restricted fashion, seems to make the best solutions. We also made it so that it runs directly in a browser as well as on a server, because we wanted to eliminate the problem of still having client-server architectures that we were seeing with the other blockchains.
Mark, what kind of trouble do you get up to at BTL?
So my role at BTL is head of product enablement, and so as a development platform, there are all sorts of knowledge-based hurdles and educational-based hurdles for people building applications on top of Interface. So a lot of my focus is both on enterprise partners and the development community, helping them with tools and educational materials and documentation and everything that they need to build the best applications that they can on top of Interface.
And where are you and Tom calling in from?
So we're in Calgary today, actually.
Is that where you're based?
We're in Vancouver.
Why are you in
Calgary?
Calgary?
This is well, it's very important in software projects, particularly long-running ones, that the layout of your teams reflect the architecture of your finished solution. So to that end, we started building the core of our blockchain out in Calgary, and then we build the platform that supports that blockchain. So basically the first consumers of that blockchain that provide services using the blockchain, we base them in Vancouver. That's worked out very well for us in terms of making sure that the patterns we see in our architecture are reinforced by the patterns we've placed in our software teams.
It's kind of like an interconnected, decentralized team structure, right?
Somewhat. It's more about just making it intentionally slightly difficult for one team to talk to the other, because it means that you have to be very deliberate about how your software interacts as well.
Interesting. Andreas, what about you? Where are you calling in from, first of all?
Hi, I'm Andreas. I'm sitting here in Vienna. The sun is shining. It's 5 o'clock afternoon.
Rub it in, why don't you?
I'm the blockchain lead for Austria for Accenture. I met this blockchain technology 3 years ago, and I fall in love with her, not because of all the cryptocurrency stuff, so I'm not a crypto head, because of the technology itself and the possibilities. And I tried to build up this blockchain know-how here in Austria and also Germany and the surroundings. I met the guys from BTL back in 2016 on an event, and short after we started the first project in the energy trading sector. And there already the Interface platform promised a lot of good stuff, and I'm eagerly waiting for the release to get my hands on this stuff from the BTL guys.
That's great. Thank you all so much for being here. And as I said earlier, we're here to discuss private blockchains, but as with much in this sector, some terms need picking apart. Some extra clarity is needed. Sometimes we need to get pedantic. So let's start with the basics. Tom, what are private blockchains?
Private blockchains are any blockchain that externalizes the access requirement. So by that I mean that, in contrast, the public blockchain must internalize the access permissions for it. So for us, we can take advantage of the fact that we can only let people in that we know about into the blockchain, which in fact mimics how the majority of computer systems around the world are used. Public blockchains are solving one of the hardest problems in both computer science and political science, I suppose, where they need to deal with many parties who are untrusted, that have very little incentive to behave well and keep a system moving forwards under those circumstances. And we believe that that actually forms the minority of the possible use cases that you would choose to apply a blockchain to.
Andreas, how are they different from databases?
Yeah, if you look at the public blockchains, and you can also say it for the private blockchains, it's not a database, it's a store of transactions. You have a consensus mechanism implemented, which a normal database don't have. And the transactions in the database or in the blockchain are de facto immutable. So that's for me the main difference from a database. And depending on the use case, of course, you can implement a private blockchain and use it like a database style, yeah. But it must be low value use cases. For high value use cases, example, peer-to-peer payment systems, you cannot use it as a database. You have to use it as it is in the public blockchain. You have to use it as transaction layer.
And
so
why
I
would you?
Actually add that,
yeah, jump in, Tom.
Sorry, that the differences that we see between a traditional database and a blockchain are beyond what Andreas said. We also see it as bundling an application server and a database together. So we're focused very much on the ability to execute arbitrary computations as well. So almost like, if people are familiar with AWS Lambda or other such services like that, it's really about being able to compute things reliably and be assured that the computation was correct, was not faulty from benign errors, but was also not faulty from malicious errors as well.
So and how would a private database do that? Sorry, private blockchain. How would it do that?
Yeah, so maybe I can add a little bit of sort of like pull this up a little bit into sort of getting the right mental model. One of the things that I think most people have probably heard about is Ethereum talking about their Ethereum virtual machine. Mm-hmm. And I don't think this has received enough attention. And I think it's actually a really, really helpful and powerful mental model for what blockchains are. So when I think of a blockchain, the public ones in particular, but also the private ones, because they're similar in structure and model, they're really just distributed computers. So when we start thinking of them in terms of just transactions or just databases or these kinds of things, I think that limits the model. And so if you think of a blockchain as a distributed computer, then you can start asking, you can start thinking about use cases, and you can start thinking about, which applications would benefit by being built on a distributed computer. And distributed computing is really the aim of most large enterprise application development. And so blockchain, if it grants you that, then all of a sudden there are a number of applications that benefit by being distributed.
We'll get into some of the use cases further along, because already my head is whirring with questions about those. But I'd like to keep focusing on the private blockchains, what we understand by them. Tom, let's talk about what private blockchains can't do at present. What are some of the limitations?
Some limitations of private blockchains currently are an inability to easily execute large compute loads. So anything that has a large computational requirement, and that's really a result of the fact that you have to run the same calculation on every computer participating in it. So in the redundancies you gain, you lose efficiency or speed. So you wouldn't want to use it for high compute capacity. But for the majority of other use cases that we see servers being used for, basically if you could rewrite your app to be a pure function, or if you could use one of the function as a service models from Azure or AWS, then you can do it on a blockchain.
Going back to what you were saying about the large compute load and the redundancies, is that's a scaling issue?
No, that's a software pattern issue. It's an algorithmic issue. It's an issue that with the current algorithms we have for building blockchains, I mean, the name itself, a blockchain. So a chain of basically synchronization points where you synchronize the system, everyone agrees that that's the sync, and then you chain it to the sync point before. That lends itself, it sort of results in the fact that you will always have that as your bottleneck. Now, there's no real way to get around that, mostly because of the time it takes for a network packet to travel around the world. So there'll always be that bottleneck, which is why very early on it became apparent that having multiple blockchains was the only way that you were going to be able to make any headway on the scaling issues.
And that's one of the things that Interbet is hoping to fix.
Yeah, that's we realized that you can't sort of retrofit existing technology to handle multiple blockchains, but it's more around being able to allow pieces of your system to operate asynchronously is really the key to speed. And the majority of blockchains we see currently are trying to make one large blockchain for the whole world,
which will bring up the latency issues that you mentioned.
Yeah, well, it already has. I mean, all of the scaling issues we see in the public chains are related to that fundamental limit, and there's ways around that limit. But I think you have to trade off a bunch of things that make it undesirable.
Yeah. Andreas, do private blockchains have handicaps that differ from those that public blockchains have?
First, I want to add something to the answers from Tom and Mark. Mm-hmm. I see public blockchain like Ethereum or Bitcoin. I see it as IT infrastructure. I don't see it for cryptocurrency and trading. So I really look at this public blockchain when I'm working on a use case. Can I use it as infrastructure? Because it has some really great advantages. But it has limitations regarding scalability, because a lot of time in this time you need to mine or to validate a block is not used for collecting the transaction. It's used for the consensus mechanisms. And that's the bottleneck. The private blockchains have some limitations. You have to set it up right to have this at least the same level of security like public blockchains. And you have to set up and run your own infrastructure. That you have to be aware if you set up a private blockchain. But beside that, you can eliminate a lot of, I think, hurdles or limitations of the public blockchains like speed, throughput, energy consumptions, governance, operation cost fluctuation, and so on, with the use of private blockchains or DLT, distributed ledger technology. But you lose some distributed effect, you lose some security, but normally you can live with that, you can manage that.
And how about something like, for instance, CryptoKitties that clogged the Ethereum blockchain? Can you see something like that ever working better on a private system?
CryptoKitties?
Yeah. So
sorry,
CryptoKitties has the problem that it's trying to fit through one chain, and that also that chain is being used for other tasks as well. It would, in my opinion, be ideal for CryptoKitties to have their own blockchain, or in fact, make one blockchain per kitty.
How would that look? That's interesting.
Well, you can get pink ones or blue ones.
You have a use case.
Tom, do you have a CryptoKitty?
No, we actually use CryptoKitties as the introductory problem for all our new hires as to why it's hard to use existing blockchain apps. And basically we say, hey, your job is to come back with a CryptoKitty. It usually takes them about 8 days.
Okay, so if any of our listeners are thinking of applying for a job at BTL, you now know one of the secrets. Mark, let's pick a part.
Can I have just one addition to the goals of Ethereum Foundation?
Yeah, absolutely.
They see these problems and these limitations, and they work on it, like with Casper, with this proof of stake consensus mechanisms. The next thing will be sharding. And there I really love Vitalik and his blog posts and interviews. They don't know when they can do it, because doing that in a public environment, public blockchain, is really, really hard. So there are ideas, concepts, which maybe solve this scalability bottleneck, but we are not there. It's a long way to this point that this will work, and nobody knows when it will work and if it will work.
Do you see us getting there sometime in the next years? Sorry, jump in, Tom.
I'd like to comment on what we've observed as a software team on the nature of blockchain problems, and it has caused considerable pressure internally for us to realize that blockchain solutions, when you're building an actual blockchain itself, it is remarkably interconnected. So we are seeing a very monolithic structure in the way that our code is written, and one of the consequences of that is that unlike traditional software projects, or the software projects that the majority of us are used to over the last few years, it's extremely hard to upgrade or migrate or incrementally improve blockchains. We have found, for instance, that the number of features that will come out, like you kind of need to have all of your features all at once, or else it's incredibly difficult to alter the code to do something that it wasn't designed to do at the outset, just because of the fact that there's so much cryptography involved and so much correctness needs to occur in the system. Everything's very tightly coupled. Upgrading blockchains is extremely hard, and I think we can see empirical evidence of that by considering the feature set of Bitcoin and the feature set of Ethereum. There have been very few fundamentally new features added to either system since its inception. And one of my fears is that our blockchain will suffer that same fate, and I'd like to suggest that that's probably a trait of all blockchains that are built both now and in the future.
Can you think of any workaround that might be able to make it more agile going forward?
Well, the only thing we've come up with is trying to build basically a chassis, so a blockchain chassis, and then making whatever you can make pluggable, make it pluggable. So make the encryption algorithms pluggable, the consensus mechanisms pluggable.
What do you mean by pluggable?
Pluggable. So we can, or any system that makes its encryption algorithms pluggable can upgrade or change at any time, because you make the system just simply rely on them for, like, hey, encrypt this. Okay, it's encrypted. Here it is. And then that frees the system up to be able to adapt to any foreseeable problems. So if some of our core algorithms are compromised, we can, naturally, someone's going to find a way to fix that, we hope. And then you just put that in, or other use cases like IoT devices or things like that will need a lower grade of encryption due to their resource constraints, so you can swap that out as well. But I mean, that's just sort of standard computer program design, really.
That's
Andreas?
interesting. Can I ask Tom a question?
Yeah, sure.
My assumption always is for private permission blockchains, the governance issue is not that hard because I have control about the nodes. So I can upgrade to an Interbit 2.0 with new features. Would it be so hard to migrate from 1.0 to 2.0 because of the data beyond, or what are your concerns?
No.
Updating is not easy.
Yeah, if we released a new version, you would find your upgrade path very early. But I was more referring to what we see as a problem with all blockchains, in that we can make small improvements and we can make pluggable improvements, like changing the encryption algorithm. But the fundamental design of the platform, we fail to see how to change it significantly without starting again. And I think that problem exists in the Ethereum and Bitcoin code bases. It just simply seems to be the nature of the problem.
And the bigger they get, the harder it's going to be.
Of course, the main is
more users.
You see this drama when they try to fix a scalability issue and they cannot agree on a new path because 80% of the guys has to install it, and there it starts the issue in the governance in these systems.
And you're right, Andreas, it does raise interesting issues of governance and the difference between the private blockchains and public blockchains in that. What's the main difference you see what are the main advantages in terms of governance in public blockchains, bearing in mind the objective is to get big?
Can you rephrase the question? You mean what's the problems with governance in the public blockchains?
More like what's the problems with governance in private blockchains as compared to those in public blockchains?
If you have a clever setup and 20 parties agree to use a private blockchain setup, then you agree, okay, what we're doing with software development, how our release process and so on. So you can talk beforehand, and then when you run the system, you just upgrade as agreed, or when you have new features or you find a bug, you can easily upgrade your 20 nodes or whatever. You don't have to make an overall consensus with every node. Yeah? So at least you should have control about your private blockchain. So that's a totally different story if you compare it with public blockchains where you have different miners, different exchanges. Everybody has another agenda that disagree. So it's a lot easier in the private permissioned area to agree on a governance and to update and fix the chain.
And this sort of leads into another term I'd like to pick apart, which is decentralization. Andreas, what do we mean by decentralization in the private blockchain sphere?
Yeah, I think you will not find a single definition for distributed and decentralized and centralized. So in my world, if you're talking about decentralized systems, you run more nodes. They have equal rights, equal architecture, but are working together. If you compare it with a centralized system, there's one server, maybe has a backup system in another data center, and that's it. Decentralized system has more computers distributed. It's like Visa is distributed, decentralized, Netflix, Facebook, that are all decentralized systems. But are they really distributed? Then you can start a discussion. So it's a fuzzy. There is no description for decentralization and distributed systems. Yeah, you have to look at it in every use case.
Yeah, Mark.
Maybe let me try one out. Sure, let me try one out and see how you feel about this, Andreas.
Yeah.
So I think when I think of decentralization, I think of decentralization of control. So I think of the public blockchains as being decentralized because they're not controlled by any single external party. We sometimes see talk about, the public blockchains are becoming increasingly centralized, and what people mean when they say that is that the pool of miners is getting smaller and smaller. In a private...
Not smaller, but more central.
Sorry, it's becoming more central. So that is the number of people that are mining on on the public blockchains are becoming fewer in number. And so, in a private blockchain, they're by default distributed, and you can. Sorry, Tom's wanting to jump in, but
yeah, the number of miners is actually going up, but the pools, people are forming pools of miners, and so the actual the governance or the direction of those pools is becoming increasingly centralized, and I think when we say decentralized, we're actually talking about the political nature of it, whereas distributed is more about the mechanical nature of a system. But I'll leave Mark to carry on from there.
So then, if we take it down to the private blockchain side of things, you can build a private blockchain and distribute control. That is, you can decentralize it. So you can decentralize the private permissioned blockchain system, but you need not. You may be a business that wants to run a blockchain, and you may want to control all of the nodes. And you may want that because you want a distributed system. And blockchain gives you that sort of by default.
So, for example, if you were going to make one chain per crypto kitty, if you are the owner of that kitty, you may choose to really pull back on the distribution and make it only run on your cell phone, or only run on like 3 different computers, or you might open it up to run kind of everywhere. It's sort of up to you. You're in complete control of the kitty. Now, if you want to go into shared custody of the kitty, which is a very common situation, I understand, then you'll need to open up the control of that kitty to yourself and another authority. That is separate to the distribution of the computers that are running the kitty.
I'm imagining the kitties as we speak. So in a way, it's almost like you have to have the control to be able to decentralize.
Decentralization is solely about politics. Distribution is a means to achieve that political will. If your system is not able to distribute, then you have no chance of decentralizing. But if your system can distribute, you have optional decentralization.
Interesting. I would like to talk about smart contracts now. We hear a lot about them, but most of us aren't really clear on what they are. Mark, can you talk us through the basics, and is there anything you think we're getting wrong about smart contracts?
Sure. So it's sort of a big topic, but one of the things that helps me a lot thinking about what smart contracts are is to go back to the model that I mentioned earlier. So if you think of a blockchain as a distributed computer, the smart contracts are the computer programs that operate on the blockchain. So they can be, those computer programs can be written to mimic what a real-life contract might look like that auto-executes, which might be the smart part, but their basic nature isn't really smart or contracty. It's really just a computer program that runs on a blockchain.
And Tom, how essential are they in private blockchains?
Well, I mean, for us, they're so central that we took the rather controversial move of building our entire blockchain as a smart contract that ran on a very small version of our blockchain in the first place. Smart contracts are simply programs. There's nothing. I think the most confusing term about it is that it seems like it's a new thing or it's a different thing. It's just a computer program. The blockchain is the execution engine of that program. Smart contracts need to have a few properties that or restrictions that aren't restrictions on the computer programs we're used to. We think that the future of smart contracts is going to be pure functions or stateless functions. Now, we're already seeing a big shift in the developer communities to favor purely functional programming as a means of writing code. And the real essence of that is essential for widespread blockchain adoption is the fact that a stateless or pure function can be executed arbitrarily many times with the same inputs and give you the same outputs. that's the essence of the distribution, because it lets you check that what the blockchain is reporting, you agree with. So smart contracts it's just another word for a computer program with some minor restrictions to make sure it can be executed on a particular type of computer, that type of computer being a blockchain.
So again, using Mark's visual earlier of private blockchains or blockchains being a connected network of computers, they would be what the computer actually does.
Correct. That'd be the end result. As a user of a system, I don't really care about things like the x86 instruction set. I don't care about TCP/IP wire protocols. I don't care. What I do care about is what I think the computer should do for me, and that is the program.
And that's a smart contract. For those of our listeners who aren't familiar, and I confess I'm not familiar either, what do you mean by stateless function?
A stateless function is one that doesn't, if you run it once, it doesn't have any side effect or any, it's something that you, hang on. Why don't I give you an example, right? Like a pure function might be like add 2 + 2. Mm-hmm. And you can be reasonably sure that for the foreseeable future, it will give you back 4. But that's probably a different conversation.
Things change. Things change. May not equal 4 from now on.
Yeah, the event horizon and all that. But if you, for example, ran a function that said, what is the weather in Calgary today? That would be a stateful function or an impure function, because you're going to get a different answer depending on what day of the week it is, what phase of the moon there is, all that sort of thing.
And the previous answer could impact the current answer.
Yeah, absolutely. Like if the question was, how are you feeling today? After you've asked that 100 times, you're going to have changed what my answer is going to be.
Yeah, and if it's raining in Calgary today, then it's probably going to be raining in Calgary tomorrow, except in Calgary the weather changes so much.
Yeah, right. Yeah.
Okay, speaking of examples, let's get into some use cases. Mark, what do you find interesting?
So I really like to think about use cases that are kind of outside of the box, especially when we start thinking about scaling. So one use case that we've talked about a lot in the office, sort of in the lunchroom and other places, is building a chat app on a blockchain. And this is one of those applications. So for instance, consider WhatsApp. I think I saw the other day that WhatsApp delivers something like 55 billion messages a day. That presents a scaling problem. And building a chat app on a blockchain is sort of an interesting proposal, and it's an interesting challenge, not just from the scaling perspective, but also from the privacy perspective. So you want to make sure that those messages that are delivered to your peers or your chatmates stay private. So I think that like the future of blockchain will have applications like this, and we're working towards getting there.
And why would a blockchain be better for a chat app, or why would that be a technology to put a chat app on as opposed to the current systems?
Well, so I can talk about the way that we would do it. So one of the things that is pretty important, as we've been seeing with the Facebook debacle that's going on in the news right now, is all of the data has been centralized into a single location. But if you were to build a chat application on a blockchain like Interbit, you could actually have peer-to-peer blockchains that would manage those particular conversations. So Andreas and I could have a blockchain that was that had permissions that just we participated in, and our chat conversation could take part on that blockchain. So this is one of the ways that we sort of approach the scaling challenge.
Yeah, so our preferred architecture for chat applications is that you should have one blockchain per chat thread, or in terms of WhatsApp, it would be one blockchain per WhatsApp group, where you'd just consider direct person-to-person messages as a special case of a group that contains just 2 people. So why that's good is because when you add someone to the group, you're really adding another participant to the permissioned blockchain. And then when you want to remove someone, you're just removing them from that permissioned blockchain. It also means that you can delete the entire blockchain and you've wiped all of the message history. It also means that as a service, the provider of the application might choose to supply you with computing resources to keep your chain running while you're not there. But if you so chose, if your privacy requirements were such that you wanted to provide your own servers to guarantee your privacy, then you'd be free to do so. But in the case of Facebook, we have a very centralized store of data. It doesn't break apart well.
Tom, are there any other use cases you're looking at that you particularly find interesting?
I particularly like software as a service applications because I like the fact that we can see how to remove servers in the client-server architecture. So being able to run all manner of software as a service offerings. Like, I mean, I'd even take a web page, just a plain web page, as the very most basic case of a software as a service app. So for us, being able to run a web page with no servers is pretty useful. So a completely distributed way to view and update information, like, for example, Wikipedia would be a great one to put on a chain. And then be able to make it run where if I want to donate to Wikipedia, I just supply my computer and my bandwidth and be like, hey, I'll help run the Wikipedia blockchain and help distribute it that way. Yeah, so definitely, rebuilding of software as a service apps, rebuilding of the web, basically, that's what I'm interested in.
So when you say no servers, do you mean rather than there being 0 servers, there's hundreds of them, more distributed? What do you mean by no servers?
Well, by the end of servers, I mean that I think that servers are the ultimate in centralization, and the majority of apps work this way. And I think if we take a step back and kind of look at how computing has gone, we started out with very centralized systems like mainframes, those kinds of things, and everyone would log in to use the mainframe. I don't think that the modern data center is much different than a scaled up mainframe. We're all stuck in this problem of having to log in to the distant remote computer. Breaking that apart to have wider distribution of computing, general purpose computing and general purpose networking, I think is essential to being able to democratize how we operate as a species. And I think that what I mean by end of servers is that servers become your peers, like they become your equals on the network instead of the privileged position where current server architectures leave us, where we have to trust what they say. We have no way to check that they operated correctly. It's just, I said, this is the state, so therefore this is the state. Whereas if you turn the server into an assistant or a helper, then the power comes back to the users of those applications.
We could have an entire webinar just on that. Andreas, what use cases have you looked into that we haven't talked about?
Yeah, 3 years ago, as I explored the blockchain, I was fascinated from the possibilities from this technology in the public sector. So I'm convinced this technology is a natural fit for the public sector, because you can put registries like land registries, company registries, and so on. We know all these examples on this blockchain technology, and you don't have to trust anymore. You don't need this middleman, which is the government. Yeah, so we need this government for we cannot get rid of the government. Yeah, for sure, in the administration, but they manage our data. They manage the fundamentals of our society and economy. In some countries like Canada, in Austria, Germany, that works pretty good. We have no security issue. But if you look in other countries, in the East, in Africa, and so on, they have huge issues. And if you put this basic information which a society needs for building up the economy on blockchain technology, that would be a huge boost for the economy, because corruption and is then, at least on a low level, not possible anymore. The next thing, and that's already possible with the technology now. The next thing I'm fascinated is all this identity topic and self-sovereign identity, which Tom and Mark spoke about. So imagine you have your identity on a blockchain and you own that and you can use it. It's also really a powerful use case for blockchain technology. And another area where I dive now a little bit deeper are microinsurances. So get a platform with peer-to-peer payment systems and a smart contract engine on top. There you can offer insurances really for $2 or $5. At the moment, it's simply not possible because the operational effort for administration for insurances is way too high to make it possible to run $2 or $5 insurances on a large scale. And that are the use cases I'm looking in, and I'm fascinated of that because you can do a lot of good stuff with this technology.
Pulling on the identity thread a bit, Tom, we're seeing some reports in the mainstream media that GDPR, which is the new data regulation that we have coming down in Europe, can kill blockchain development. What's your take on that?
I think that the only way you're going to really be able to comply with what GDPR is requesting is to be on a blockchain. But I think that the statement that it would kill blockchain development is really taking the view that blockchains are centralized. So in a single blockchain environment, no GDPR, you're not going to be able to comply because you can't punch out bits of data in there as that legislation asks. And I mean, this is just the beginning of GDPR. It's not like it's going to be relaxed. It's just going to be increased as people start to expect it more and more, and it will get refined, and we'll see violations of various sorts, and people will adapt to that and so on. I think that really what it's about is making sure that people who hold confidential information are very orderly about how they manage that data. If you want to be able to delete a user's data, you must first have made sure that you've managed all of that user data correctly. And I think that having one blockchain per user is the cleanest way that I can think of to make sure that you have all the relevant data in one single place. Now, one of the biggest problems that I can see for complying with GDPR is if you've got all of your user data in one large database or a handful of databases, you're going to back it up periodically. When you back those things up, you're going to seal it, you're going to sign it, you're going to do various things to it. So if you want to delete a user's data and genuinely delete it, you need to pop open all your backups, all your DR systems, and punch out that data from there too. This is not a feasible way to operate with the current computing systems. Now, if you consider what having a single blockchain would mean for that type of problem, you've kind of compounded it, because now not only is all the data in one spot making it a great target, you also cannot delete it. So the real only solution that I see is if you have one blockchain per user account, then you can cleanly, succinctly, and completely delete the entire blockchain, and you can be assured that you have genuinely wiped all of the user's data at their request.
And so private blockchains
Can I add
would be...
something
Yeah,
to that?
jump in, Andreas, jump in.
And there is also a wrong understanding of identity on the blockchain. If you're putting your identity on a blockchain, you don't put your data on there, and never put data on there which you don't want that you want to delete afterwards. What you're doing here is you just store the hash and the signature on the blockchain of this data. So you can prove that you have this data, but you never store data on it. And if you delete the data, the file, yeah, then nobody can do anything with just the hash code of this file in your identity. It's also deleted. But that's a huge question. Where you store your data? Are you responsible on your device? Will there be a data vault which you use for this distributed identity and so on? That's a huge open question. Where will you store your data if you talk about decentralized identity or blockchain identity?
And again, we could have a whole separate webinar just on that, but drawing on what Tom was saying, it could perhaps be the perfect case in which private blockchains complement public blockchains, private blockchains being where the data is securely and stored in a distributed and alterable way, but the public blockchains are where the immutable transactions take place.
Possibly, but it really comes down to saying that every user should have their own dedicated database, I think is an easy way to think of it.
Yeah. And every now and then I read somewhere that private blockchains will disappear, just like the intranets did. Andreas, what do you think of that?
Nobody knows, but I doubt that. And yes, this analogy between intranets and internet is nice for a presentation, but it don't get the point. And intranets are still up and running. Maybe in another fashion, not as intranets, but every company has its own walled garden information system or whatever, or intranet. So they're still up and running. They are there. And if you compare it with blockchains, it's like there will be a single instance of an Oracle database. That's ridiculous. It will not happen. And I think the same will happen here. Yeah. I hope that public blockchain get more mature, because it's really, really a great infrastructure for small projects and really great. But it will not be the only one infrastructure. There will be separate one. And I think there will be private blockchains up and running as now ordinary databases are in the data center and running. So don't think they will disappear.
Only just as the intranets look very different today, so will the private blockchains look very different tomorrow. Tom, do you think private blockchain use will ever go mainstream, or will applications be powerful but limited? And what do we even mean by mainstream?
I think that anywhere that you use a database today will be replaced with a private blockchain.
Anywhere?
Anywhere. It's just a better way to do databases. Whenever you have a database, you always have an application attached to it. Now already those things are free to drift from one another in terms of their consistent view of the world. A blockchain combines those two things together, and if you couple that with the advantages you get of being able to have a single database per object that you're tracking in the world, it's just simply a cleaner way to manage data in general.
A saying I've always liked is, success does not mean not having problems to solve. It means not having to solve the same problems as last year. And Tom, what do you think will be the next set of issues to solve with distributed ledger technology?
Well, the next set of problems is most definitely going to be education, because right now everyone thinks that we're a cryptocurrency, and then the next sort of
your share price behaves like, yeah. If you look at the share price of BTL and Bitcoin or Ethereum development, it looks very similar.
Yeah, but it's also that, like, I hear people saying the blockchain as though there is just one, or put it on, you know, and it's really like, I mean, this is just the beginning, and I don't want to get bogged down in what we're doing as a company or anything like that, but it's just simply a better way to compute. It's a better way to build the internet. It's how, like if we had a chance to make the internet again, we would definitely do it with blockchains. And so the problem facing, there's so much like competition between blockchain companies and blockchain people. As a whole, we are trying to make computing better for people as an industry as a whole. And I think that the biggest hurdle we got to overcome is making people understand that there's nothing special about blockchains. You don't need to understand what's going on inside it, just like you don't understand what's going on inside the CPU of your cell phone, or how electromagnetic radiation is used to transfer data from you to the cell tower. Like, it's more about, like, it's like if you just start demanding a better quality of service, a better resiliency, better uptime, better data management, less data breaches, more transparency, demanding control of your own data. That's really the problem for us to overcome as a whole. Education, understanding, and that desire for a better permanent internet.
That sounds
Fully
beautiful.
agree.
Yeah, it sounds beautiful. Mark, in your conversations with clients, what are they hoping for? What problems are they mainly trying to solve?
So, I mean, there are a number of types of problems. I mean, a lot of the conversations actually sort of dovetail on some of the things that Tom was talking about. I mean, people know that this is sort of the direction of computing and where it's going, but they're trying to understand how blockchain can benefit them. And so, at the very basic level, we spend a lot of time talking to our clients about, just the benefits of distributed computing, but also blockchain affords you the feature of being able to do shared computing with counterparties. So one of the projects, the one that we worked on with Andreas, was a peer-to-peer energy trading platform. And so it enabled two companies who never would have shared a computing platform previously to manage the trades that they carried out with one another on a blockchain. So there are those sorts of opportunities that are coming up all over the place, and I think that a lot of this is about education. A lot of this is about helping people understand how it can make the way that they're doing computing better.
Let's hope that we've managed to advance some today. I knew that the hour would go by fast, but I wasn't expecting it to go by that fast. We're not quite out of time yet, but almost. I want to ask you, Andreas, what most exasperates you about work in the private blockchain sector today?
Can you rephrase the question? I don't get because I'm the only not native speaker. Perhaps
Sure. No, it was a bit convoluted.
Sorry.
What drives you mad? I'll be very blunt. What drives you mad about private blockchain work going on in the sector generally? Obviously not BTL, but in.
Okay. What really drives me mad are all these freeloaders who just use a blockchain or just a tool, set it up, and claim, now we are using blockchain, we have a blockchain tool.
We're cool.
And beyond that is just a single node fabric or something fused together with Fabric Composer and so on. And then you have all these press releases, and that drives me really mad because that's simply not blockchain. That makes me nuts. Yeah. And everybody's claiming we are using blockchain. And if you see, they're just clicking around with a Fabric Composer. Yeah. And that's not blockchain. And whoa. Yeah.
Can we
jump
clap
in, Mark?
for you, Andreas?
Jump in, Mark?
Can we clap for you?
I think we can. I think we can all agree with Andreas on that one.
And that's the thing that's doing a massive disservice to moving the internet forward, is people claiming, the freeloaders saying, we're doing blockchain. And the question is, okay, what blockchain are you using? And how is what you're doing leveraging any of the benefits of blockchain? So, yeah.
And let's not even go into those that decide to plug blockchain into their name because it's good for the share price.
I see.
Mark, Mark, what do you think we're going to be seeing in the short term from blockchain development in general?
In the short term, I think that we're going to see a lot more sort of high enterprise grade POCs, and also I think probably this year we're going to see some really properly commercialized private blockchain projects. The last year was sort of a lot of hype about the public blockchains, and it brought a lot of awareness and attention, which did trickle down for sure to the to talk and conversation about private blockchains. But now, sort of a lot of the investigation is both ramping up and projects are turning into commercialized projects.
And Tom, what about Interbit? What developments can we expect in the short term there?
Well, first you're going to actually see the thing itself coming out later, but we're going to start showing how blockchain applications can interact with each other. So once you get used to the concept of having multiple blockchains per solution, then things start to get really interesting when you learn that you can connect those solutions to each other to compose even wider solutions. So it's almost like rolling out microservices across the internet, where each blockchain is a microservice and they operate in reliable concert to provide solutions to end users, which I guess is really what it's all about at the end of the day, making sure the users have a better experience. So we're going to be launching our Interbit platform. It's going to be in a very early test phase, but we hope that people can see what we were intending to do, such as being able to set up your own identity blockchain that holds your personal data, and using that identity blockchain to interact with other applications on our network of blockchain applications, and ultimately inviting developers to get on board with making applications that can then sit in our store, so that others can purchase them and use them using microcredits and small payments and all that, so that we can really start to break down the size of applications to make them smaller, more transparent, more reliable, and more widely distributed, whilst having much, much greater respect for users' data and privacy.
And when will this be happening?
On April 23rd, we're going to be open sourcing our platform repositories, so giving people a view of the code that runs the apps that we've built on top of our blockchain, and also inviting people to sample and play around with our hosted versions, or the versions that we are operating for people to see and experience what it means to have a blockchain in the browser, and what it means to be able to deploy your own blockchain with just a few clicks.
And you're going to be at our conference Consensus this year, is that right?
Yes, yeah. We'll be at the conference, but we're also going to be hosting a hackathon on the Saturday and Sunday before that, on May the 12th and 13th, where we were privileged enough to sit alongside Ethereum, Hyperledger, and a few others, and we actually get to pick one of the topics. So people are going to be given a problem that the organizers of the event have picked for one of the days, and then the other day we actually get to pick what happens. So it'll be a pretty interesting experience, I think. Hopefully we can show how to use Interbit for solving those problems.
Can you share the problem that you're going to pick?
Yeah, for sure. Our problem is going to be, you need to make an app that can delete its users' data.
Cool. And if any of our listeners are interested in getting involved, how could they find out more?
There's a website up. You can reach it through our main website on interbit.io. You can also look at the consensus registration for the hackathon. There's a lot of pages on how to sign up there. And if anyone wants to sign up for that and wants some prior education on how to use Interbit beforehand, definitely get in touch with us. We'll help you out.
And Tom, how can people find out more about what you're up to?
Keep an eye on the interbit.io website. As soon as we're able to release information, we'll put it up there. We have a number of restrictions around being a public company and disclosures, but interbit.io is the place where everything happens.
And Mark, what about you? How can people follow you?
I mean, my information is available on the Interbit website, but you can also follow me on Twitter at @m_Barber. I'm not very active, but I will certainly respond if you have questions about Interbit. And yeah, I will be at Consensus as well, so please do come by and say hi if you're there.
And Andreas, how can people follow what you're up to?
I'm active on LinkedIn, so if you search me, Andreas Freitag, on LinkedIn, you will find me. Unfortunately, I will not be in New York. It's really a shame.
It's not too late, Andreas. It's not too late.
I will try to find budget for the slide.
Excellent. We hope to see you there. And thank you all so much. This has been great fun. Thank you also to our listeners. I hope you learned as much as I did. We'll be putting the recording of this webinar up on our web shortly if you want to listen to it again or if you want to encourage your friends to do so. Thank you to our panelists. Thank you to all of you. And I hope you all enjoy the rest of your day.